introduction. I'll be talking about AI and ML in general. I'll try to make it as informative and as descriptive as possible, but we'll be mostly going through different topics. And finally, talking about how we can leverage AI in Salesforce because this is a Salesforce group. I don't have a lot of experience with Salesforce. I am an AI ML engineer, but we'll talk about Salesforce as well. So to start with, I don't think there is anyone who hasn't worked with AI or at least used AI, right? But this goes a long, long way back, and it's history actually. So let's start with you must be hearing about a lot of buzzwords around AI, like AI, machine learning, computer vision, OCR, and a lot of different stuff, right? But what I'm going to do is try to break it down in terms of how the subset and superset works. So AI is the biggest superset, like everything that you hear is part of AI, which is artificial intelligence, which simply means making machines understand data. Now, there is narrow AI, which came on earlier 90s and 80s, which was very descriptive tasks being done by computers and programs. So that's why it was called narrow AI. Then we had machine learning, which is a subset of AI where we have historical data and we try to do things based on that. Then we have deep learning, which came around 2010, 2012, which changed the whole scenario for AI and machine learning. Like AI was not doing that much in the industry till 2010, but based on deep learning, everything changed. I'll come to the part why it changed and what was different. And then recently, you guys are hearing about generative AI. That's also not quite new. It was there since 2015, 2016. But what's new is LLMs, which is large language models, which is based on GPT. Chat GPT is one of them, which is generated pre-trained transformers. I'll again come to that. And finally, what you're using is GPT-4, which is a chatbot called Chat GPT, which everyone knows. So this is kind of breakdown of how AI is structured. And again, there are a lot of other words as well, but this is a subset and superset of how it works. Right. So this is kind of history, and it started around 1950s. And have you guys heard about John McCarthy or Alan Turing?
Yes. Yes.
So generally, John McCarthy and Alan Turing are termed as founding fathers of AI. And what Alan Turing did in 1940 was the World War II was going on, and there was a machine called there was a code called Enigma formulated by Germans, which was almost unbreakable. And he devised a hardware machine which was able to break that code. There is a movie about it called The Imitation Game. Yeah. So what happened was he created a hardware machine where you can actually turn different knobs, which was basically different permutation and combinations for each character. And finally, it landed up and cracked what that input meant, right? And that is the foundation of what we call the neural network, right? And then he devised, he started a statement, like he gave a statement which was later called the Turing test. Doesn't even know what's the Turing test?
Yeah.
What is it?
Doesn't determine if something's intelligent or not.
Yeah. Correct. So that test was simple that if in time, like if in future, we are able to devise a machine that a human is sitting on the other side of the wall, machine is sitting on the other side, and human talks to the machine and cannot make the difference whether he's talking to a human or a machine. If we have such level of machine, that machine will be called artificially intelligent. We are very close to that now, right? And that point in time, when we are not able to distinguish between machines and humans, when machines have human level intelligence, is called AGI, which is artificial general intelligence, the point of singularity. That's very far. But so 1960s, 70s, we had this artificial intelligence. People were doing research on this thing based on mathematical formulas, but we did not have enough computational power. The hardware was very expensive, was very slow. Machine learning started gaining more traction and more. It came into limelight because people started getting more data. So by 1980s, we had much more data available, and then machine learning came into picture. Fast forward to 2010, Google released Google had it already working in their internal organization. They termed it deep learning, and then they open sourced it by the name of TensorFlow, and that changed everything. Coincidentally, I started my graduation in 2010 and I got hooked to it. So, uh, but I was not aware about deep learning until 2013-14, but I started doing machine learning around 2010. What changed was we started getting more powerful GPUs instead of CPUs, which NVIDIA mostly bet on. And the computational power was exponentially high. We could compute like 1,000 times, maybe million times faster than the CPUs. And the size of GPUs like started becoming smaller and smaller, and we had the nanotechnology, like these smaller nanotanks. What changed in machine learning and deep learning? I'll bring you to that. But as we talked about, like it's ancient. People were trying to figure how our brain works, and that's the model on which AI is generally modeled on. The neural network that you hear, it's tried like people have tried to base that on how we think and how the neurons in our brain fire. They tested it on a cat in like early 60s and 50s, right? How the signals flow through the brain. All right, Stephen Hawking said a very nice thing that AI will be either the best or the worst thing ever to happen to the humanity, and we are yet to figure out. Um, AI winter 1970s, I just talked about it. Like people started figuring out that we can build machines which are intelligent, but because we did not have enough computational power, everything was just theory. People had theorems and theories proved, but they did not have enough computational power to prove it. 2006 in this part, I think most of you have heard about that. Go software based on deep learning was able to beat the world champion. And that was again one of the biggest landmarks that machines are getting more intelligent than the humans. Okay, so this is when I started working on AI. And I was using MATLAB. Has anyone heard about that? Okay.
Oh yeah.
Yeah, so the weird thing about MATLAB was the index starts at 1 instead of 0. And I got into a very bad habit. So this is when I started doing machine learning. And as you can see, the prediction, like it shows it can see a car up there in the tree with 99% confidence. Right? And this was the best state of the art at that point in time. And this also tells you that accuracy is not the only thing or not everything. Like we'll talk about that later. But this is when I started working, and people were trying to figure out how to improve these things. But to talk in general, I think most of you are familiar about normal programming languages or what we do in programming, right? So what is different between programming and machine learning is that in traditional programming, you have rules and you have data, and then you generate the output. That you write the rules based on some database, some data, and then you generate the output. You return the response if you're updating APIs. In machine learning, you already have some output, some historical data, and you combine that. You know what desired output you have some historical data, and then you try to figure out the rules based on that. So this is something that made me understand the difference. And coming from traditional programming, I took this to heart to switch to machine learning, because if you understand this part, you'll be able to relate more to machine learning. That you are taking output data and you're trying to figure out the rule based on it, and that's why it all matters. All right. Okay, so I'll quickly walk through this. I have a lot of slides, but that might be too much into technical details. Before 2030, we had traditional programming where we did a lot of hashing, crossing, bucketing. If you don't know the terms, it's fine. But basically, we were trying to figure out relations between the data that existed. Later on, when we had machine learning 2015 onwards, open source community started releasing embeddings. For embeddings, just think about them as 3D vectors like in space, where you have things already in relation with each other. For example, uh, let's talk about words, like I'm talking about word embeddings. So we are using ChatGPT and all that, which generates an output, right? It's generating a sentence based on your question. But how it's figuring out what word to type after the current word, right? So there are embeddings which have relation of all the words that exist in the dictionary. For example, king and queen, it's a very common example, are quite close in that 3D space. But king and kitchen are quite far, because based on all the data that it has read, like whatever textbooks, whatever history it has read, it found that king and queen are mostly used close together, but king and kitchen are very far. So that kind of creates a mathematical formula that how the words are related to each other. And that's how we learn when we start learning any language. We'll talk about English. We just learn the letters first, then we learn the words, and then we try to learn how to create sentence verb. So that's the idea of how machines started learning how to create sentences. So, if this. What I'll try to do is I'll try to walk you through a general life cycle of how a machine learning project works through all these stages, and then we'll go into details of few of them. Right. But before that, do we have marker? Okay. So I'll talk about one of the earlier use cases. Like you are using ChatGPT since 2020, right? But this generative AI started around 2016. And what generative means is that you want to generate something new. Like you are not predicting something existing, you're trying to generate something new, right? So you must have seen chatbots even in 2015, 2016, early age of chatbot, which were trying to reply. And in 2017, Facebook started those messenger bots where you could like book a ticket, book a hotel, and all those things. So at that point of time, the algorithm which is the base of what you use in ChatGPT. So we have a
Yeah, go black or
Yep.
brown.
So two things which were used a lot were LSTM and NP. What I'm trying to explain is that it's not very far from now. Like it only happened in 2016, like maybe 8 years ago. And I'm just trying to explain how quickly things have changed. It has changed dramatically. So I'll talk about this first. This is a mathematical algorithm which is called long short-term memory. And a simple formula for this was that AI took three words. For example, this is up. Then it whatever data it had, like maybe it has read thousands of books. It tries to figure that what next word fits best when we have these three things. So maybe in all that historical data, it has read that this is a boy fits best after these three words. It's called long short-term memory because now it will forget this word. Now it will take these three words. Now it will try to figure what is the best word after these three. So this is a boy, maybe who. And then it will forget this. It will take these three and will keep on moving. And that's how it was generating sentences in 2016, 2017. And that's why it was generating a lot of gibberish as well, like something that did not mean anything, right? So this is a boy who flies or something like that. So because it did not have any context, what it was trying to do is based on every three sentence, it was three words, it was trying to just predict the fourth word. That was it. And another thing that changed a lot about this was NER, which was name entity recognition. So the chatbots in 2016 were like book my flight to Paris in 2 days. So it tried to figure out what is the name in this particular line, what is the entity, these two things. So for example, the name is Paris in that particular sentence, and the entity could be flight. So there were algorithms which were able to figure out in a particular sentence what is the name, what is the entity. And that's how the chatbots were working in 2016, 2017. Right? But this was also generative AI. So generative AI is not new, but LLMs are new. Coming to what changed and how everything evolved after that. Google released a paper in 2017 or 18, and I will recommend everyone to just read that. It's a research paper. You might not understand a lot of it, but still, that's how everything changed. It's called Attention is All It Takes. That's the name of that research paper. And they thought about it differently, that we don't have a context right now, and that's why we are predicting gibberish. And OpenAI took that research paper to heart, and then they built ChatGPT, the first transformer model, which was able to not just have these three things in memory, but also have the context of it, that what we are talking about. And that's why they were able to predict more better sentences. So still what you're seeing in ChatGPT, it's still predicting the next word and the next word and the next word. But now it has context with it, and that's why it makes more sense. But still at times you will find it writing gibberish. Like now it's grammatically correct, but sometimes it doesn't make sense. Right. So this is the history and the logic behind what you're working on right now. Can we switch to that back? Does anyone have any question on this or any input on this?
So it's still the same thing, but we have more data to go with it, right? More time.
Right. And even the algorithm changed. So now we are not using LSTM.
Yeah.
They did few more things, like Google released an algorithm called BERT. This was bi-directional. So they started going
No.
with both directions, having context.
No.
And now what ChatGPT did was they had a concept called, I'm not going into mathematics of that, but transformers, where they have both directions as well as its relation to already existing sentences, which makes sense. A lot more context, basically. For example, in 2017, it was a big breakthrough when you asked Siri or Alexa that who is Don Mayer and what is his age. So in the next sentence, it was able to understand that his age means John Mayer's age. So it had the context, and the context lasted only 2 questions. So that was a big breakthrough in 2017, only 7 years ago. Any more questions on this? I'm not going into the mathematics of this, but I'm just trying to explain how quickly it has evolved.
Can you share the?
Yeah.
Yes.
Presentation. Yeah.
You can share it.
Oh.
So roll me if you can. Awesome. Perfect.
All right. One major thing that has changed again is that till 2017, 2018, or maybe let's call 2016, when you were doing machine learning projects, you had to do a lot of groundwork. You had to do feature engineering, which was like identifying what is important, what is not, and all that stuff. What changed with deep learning is you don't need to do feature engineering anymore. You already have the features, which because they like it can calculate trillions and millions of combinations in seconds and in minutes, which you cannot do mathematically. So that changed a lot. A lot of groundwork does not need to be like you don't need to do that now. But it's still good to understand the mathematics. But it is changing. Like it's not important, right? It's good to know, but it's being done underneath. So I'll talk about the life cycle when you do a machine learning project. First of all, is choose the business user use case. Like if you have a business use case, or if you're already talking to a business, they'll come up with something that can be improved using AI or that can be solved using AI. I'll take a use case there. We built a pricing engine for one of the real estate agents. They wanted us to create a machine learning model, which would tell them that their real estate homes, what should be the rental price for that, based on their demand, based on the views and all that. Right. So I'll take 2 examples. One thing is called classification, another is called regression. These are very basic, but I'll try to explain what they mean. So if you have apple and orange, and you try to differentiate, like if you have images of both, and you try to create a machine learning model, which when given with a new image, could tell whether the new image is either apple or orange. This is called classification. You are classifying in either of them. And this doesn't need to be just 2 things. It can be multiple things. Maybe banana. So this is just binary classification. Otherwise, there could be 10 options. Right? But you are finally landing up to one of the absolute things that is defined. Like you have historical data. You had 100 images of orange. You had 100 images of apple. You trained your model on that. And now you have a new random image. Your model is able to tell whether it's an apple or an orange. That is called classification. Another use case is called regression, where you don't have an absolute answer. But let's say I have a historical data of name not name, basically age, experience, and tech stack of all the people working here and their salary, right? And now I want to build a model which takes a new user, takes their age, experience, and tech stack, and recommends their salary. Right? So it's not going to be a similar salary from what we all have here, but it's going to be a number, a range, right? Like something which is different from all of us. So whenever you are trying to predict something on the number line, which is not absolute, it could be anything. That's called regression. So the example that I was talking about, the real estate pricing thing that we did, what do you think? Is it a classification or a regression?
Like,
Is that like predictive?
Yeah, that's predictive and that's regression because it was not an absolute number that they wanted to price their rental homes at. It was based on their historical data and it could be any number. Right? For every home, it will be a different number.
Mhm.
Some will be placed at $1,500, some will be $1,800. Right? So that's regression. Now at times, you can still make your regression problem into a classification problem because regression requires more data, more mathematics. An example of how you can do that is, now let's take that same example of the pricing model that we did. They wanted exact output, so we did the regression. But if we wanted to create it into a classification problem, what we can do is, instead of having our historical data with absolute home prices, we can bucket it. And these are the home, like maybe it has 2 bedrooms, 1 hall, 1 kitchen, and all that. And it has a price range between 1,000 to 1,500. Another one is 1,500 to 2,000. Another one is 2,000 to 2,500. So we have already, like we have historical data which was on a number line, but we bucketed it into different segments. And now we can predict or suggest a new price, which will be a particular segment. So it's an example where you convert a regression to a classification problem. So this is again based on the business requirement and all that, but I just wanted to take you through these two basic machine learning algorithms. And no matter how much you read, how much experiments you do, these two will come a lot handy because a lot of problems are just solved by this. You don't need a lot of other things. Talking about that pipeline, of course, you understand the business use case. The next thing is you collect data. Data is the most important part in any machine learning or AI project. The next thing is that you try to do ETL on that particular data. You try to understand that data, convert that into some meaningful objects and meaningful columns. And then you do the feature engineering, which now is obsolete. Like if you are working today on machine learning projects, that particular block will not be required. The next thing is, can you go to the next part?
Looks like a big block.
You want
Feature
Yeah,
engineering.
I'll try to explain that.
this one?
Yeah, like this is what we used to do historically. Like most of the new projects, you won't be doing this. So for textual data, for example, this is what I was talking about. Like you had long sentences and you had to figure out what is the name in that particular sentence. What is the stop word? Like the he, she, these are stop words. You don't need that to make sense. Like then punctuations, they'll be added noise to your particular sentence. So you had to do all these things yourself. Like you had to write algorithms which will remove the stop words, which will remove the punctuations, which will remove the like the period, the comma, and all that. But now when you use deep learning algorithms, you won't need to do all that part. Like you can skip the feature engineering in most of the projects. This is again that's historical. You don't need to go there. Yeah. Let's go to online. Yeah.
Right.
This is one example of different types of algorithm based on what kind of data you have. I have left 2 of them as guessworks, and I would like, for example, if you have an audio that you want to convert to text, or if you have an image that you want to convert to text, what do you think? What kind of algorithm will fit in there? Have you heard about any algorithms which do that? Which converts audio to text or which converts image to text?
Speech to text.
Any other?
That's right.
You're quite right.
Right.
Yeah. So the speech recognition is that the whole subset, and then inside that we have multiple algorithms like speech to text, HTF, and all that. Image captioning is something that you're using in ChatGPT right now. Like you give it an image, it can write a paragraph for it, and the reverse is also true. You can give a prompt and it can generate it. So these are different algorithms and different fields which are actually doing it underneath. Again, you don't need to go into details of them, but this is how it is structured. All right. I'll quickly talk about the different types of machine learning. Supervised learning. It is one of the most basic example, and it is where after every output, you judge and see whether it's correct or not. So it's like training a kid or training a pet that what you did was right or wrong, telling them that this is wrong, you cannot do that, and this is right. So punish on the wrong thing and reward on the right thing. So that's how the supervised learning works. Unsupervised is where you have a lot of data, you just let it be, but you have the final outcome, and then you try to compare whether that went right, whether that did not go right, and all. So example of supervised learning that you would see in day-to-day life is like whether when you get some output, you see a thumbs up or thumbs down. Even ChatGPT, it asks you like how satisfied are you with the response and all that. So it's learning based on your response. If you say I'm not happy with it, it will go back to the algorithm and say that whatever you predicted for this particular question, it's maybe it's wrong, right? So that's how supervised learning works. Reinforcement learning is that at each step, at like each step of prediction, you have a particular prompt which tells whether it's going in the right direction or not. Not waiting for the end-to-end run of that algorithm, but at each step, you are trying to declare what is right, what is wrong. Reinforcement learning is used in gaming a lot because when you're playing against the bots, there are a lot of possibilities. So you use reinforcement learning where your gaming engine learns at every step because it knows what to do at the end. Semi-supervised is that you don't supervise at all the steps, but you have like figured that these are the major milestones that I need to define for my final output. Online learning is again something that was very crucial in machine learning. Google did this first, and it was that earlier people were creating models, and then that was deployed in production. It was doing its stuff, but they had to create a new model, then deploy again because data is changing, right? Data is changing every day, and there's a term called model drift or data drift. That after some time, maybe after a year, 6 months, depending on what kind of project you are building, that model will become obsolete. It happened in COVID. Like all the predictions went haywire because all the energy predictions went haywire because they were not used to people staying at home for so long. So data changed. So online learning, what it does is that it doesn't need like the existing model gets a feedback into it, and you don't need to replace the model. But while having that model in production, it keeps changing based on the data. And Google did this first in Google Play Store. That was the first example of it. Transfer learning is something where you have one model, it learns something, predicts something, and then it passes to another one. And 90% projects at least, you will end up with ensemble learning. That's what you will be doing if you're doing machine learning projects, which is combining multiple models and then taking the output of all those models, kind of a random forest algorithm. So this is different type of machine learning. Does anyone have any question on this?
What unsupervised?
Mhm.
Unsupervised.
Unsupervised is where you are not letting the model know, or the output is not shown to the model at any point of time. You just let it learn from the historical data, and then you try to predict something. So it's not shown what's desired.
So it's like ChatGPT, if they didn't put the you like it or you don't, and then it just continues just to
Yeah.
create stuff. And then it uses that stuff without knowing if it's good or bad. So you can get a really bad trajectory of the outputs because it might be generating things that it's using, but nobody's telling it it's good or bad.
But unsupervised learning,
Learning from them.
Mhm.
Where
Yeah.
is it?
So unsupervised learning is still useful in a lot of ways. For example, when you don't know what you want from the data, right? If you have a lot of data, you can use unsupervised learning algorithms. For example, there is one called KNN. Let's say I have data of a lot of customers and I don't know what to do with them, right? I'll just use this algorithm. It will try to plot, let's say, all those customers based on their attributes. Maybe I have different attributes like their age, their salary, their usage. I'm talking about maybe phone usage, right? And all that. So it has a lot of data about customers, but we don't know what we want to do with that data. So if we use algorithms like unsupervised learning, like for example KNN, it will just plot different users based on those attributes. And then you can start figuring out that these particular users are together based on certain attributes. And then you can start making business use cases out of it. So, for example, I'll tell you another example. We built a tool which was used for churn prediction. It was able to predict that a particular customer is going to churn from your subscription, right? And there we figured one thing, which was not known to the business, not known to us, but people who had credit card payment on were less prone to churn, and people who had it like did not have credit card on file, they were more prone to churn. And later business confirmed, yeah, that makes sense because when people have something on credit card, they forget to cancel it, right? So business idea, and then they started a campaign around it that if you add your credit card to file, you'll get 20% discount, 30% discount, because people who had credit card on file were not churning or like were churning less, and people who had like manual payment on, they were churning. So this was something that neither the business knew, nor did we, but because we plotted different attributes, we were clearly able to see that this is one big difference between people who are churning and who are not churning.
Set and forget it.
Yeah,
Set it and
it
forget.
happened with all of us, right? Like, it happened
Yeah,
with me
no,
for sure.
absolutely.
So that was one attribute which was like we did not know what to predict or what to look for, but machine can generalize or try to plot different common attributes between different data points. That's one example. Go back to the slide.
Share it again. You can always override me.
Another example was this was for a home-based security company, like they were providing home security, and the most active users were people who were above 60 and retired, and that made sense because they stayed home, like they were more insecure about their home and all that they had. So, and the most churned age group was people between 20 and 25 because they keep moving and they don't like care a lot about the things they have. So again, they made a marketing campaign when they were offering people between 20 and 25 a 10% discount because they were trying to get more people on that range.
Awesome.
All right, I think
You already covered.
yeah, I already covered, but this is a tree. Like if you keep going, it's a never-ending tree, and there are a lot of different domains. But I just again wanted to emphasize on that it all starts with machine learning. I talked about the high level of unsupervised, supervised, and all that, but then they have their sub parts and their children as well. All right, now bringing your machine learning models to production is a big task because of the thing that's called the data drift, which I talked about. Because data keeps changing, attributes keep changing, people's behavior keep changing. So you don't know that something that's predicting something right now will stay true for a longer time. And for that, mathematically, we have a thing called error function or the error out, which calculates how far is the prediction from something that business expects. And that has to happen continuously in the background so that it doesn't go off a lot. And if you talk about production use cases, again, a lot has changed because of online training that I talked about, that now you don't need to discard the old model and put in a new model. You can use things like online learning where your existing model can keep on learning. So it keeps on feeding on new data and you still are predicting something which is very relevant. But there still are a lot of challenges in production. I'll give you one example that happened in 2018 with a famous airline. And that was a customer wrote on Twitter that lost my baggage, awesome treatment. Thank you. The bot replied, we are happy. We are happy to serve you again. Glad that you liked our service. Because of sentiment analysis, it found that it couldn't understand the sarcasm, right? So again, people are working on sarcasm detection. That's one of the fields. Now machine is even, and that's working quite amazingly. Like it's able to predict 90 or 80% accurately that what is sarcasm. So there are a lot of fields, but I'm telling you issues that will come in production because that was a big downside for that company, that airline, right? Like someone was complaining about the bad service and the bot was replying that we are happy to serve you. Another thing that happened with generative AI recently with Air Canada, I think anyone is aware of that. So because LLMs, they make things up, right? They have read a lot, they have read all the internet, and now they can create sentences as we talked about. But they can create things which does not even exist. They can hallucinate. That's what called hallucination. And what Air Canada did was they had a chatbot. A customer had a flight which got cancelled, and a customer just started chatting to that particular chatbot. It suggested a random flight to that customer which does not exist at a random time, and the customer sued Air Canada. And now that's a big thing, and now people are trying to get rid of this hallucination, and that's why that AI in business is a big risk right now because it can do anything. So now people are trying to make a subset of it, and that's why private LLMs or RAGs are very important. RAG is retrieval augmented generation, which is basically keeping it within a window. For example, if you have a PDF, now the questions what you ask will be based on whatever it has read in the PDF. It will not make things up. So this was a recent example where it just made the flight number, the time, the location, everything. And the customers thought it's an actual flight. He went to that counter and he found like nothing exists. So these are some of these challenges and problems that can come in production. Can you go to the next slide? All right. I think we can skip this. I'll talk quickly about the roles that exist in machine learning if you're trying to move to this AI and ML space. They're quite a different roles, but the major four roles are data engineer. If you're working as a data engineer, you'll be working on data collection, transformation, organization, and feature engineering, which is basically most of you do that in ETL processes or when you're working with databases. So when you're migrating data and all that. So that's the role of data engineer. Data analyst again, which will try to find correlations, try to visualize data, try to make business use cases or sense out of what's existing in the data. These two are one of the most initial roles in data science, but very important roles. Next is the ML engineer or the data scientist, which actually trains the model, builds the model, validates whether it's the correct model or not, whether it's doing what it's built for or not, and then does the deployment. And a very recent role that I think you might have heard is ML ops, like DevOps, and it's getting a lot of traction. The role of the ML ops engineer is to make sure that it's deployed, it's monitored. Like monitoring models is a big task now because everyday data is changing. People are asking random questions. So if you're not monitoring it, your model might be speaking gibberish tomorrow. So that's an important part. And then have the alerts in place, the dashboard in place. So MLOps is very similar to what we have in DevOps, like doing the continuous integration and deployment. If you are working with normal code flow, you have people who deploy it to production, who manage the monitoring and all that. Similar to that, we have MLOps in the machine learning pipeline, who are responsible to make sure it's going to production and then monitor it. And go to the next part, I think. All right, so now we'll move to Salesforce. We'll try to show a small example of how you can utilize Salesforce to do all this. Again, this is all mathematics. This is a lot of code, but again, there are systems which exist, which come with a lot of pre-built things. Out of like one of them is Salesforce Einstein, where you can feed in your existing data, and it comes with a lot of existing models. So by models, what we mean is there are existing algorithms. Two of them we talked about, linear regression, classification. There are many more, and like Einstein comes up with a list of existing models. You can use them. Otherwise, you can bring your own model. Like you can create your model and then export it to Einstein. So we'll try to show a small demo around Einstein, then we'll come back to Chi. All right. Any questions?
You ever thought about teaching a college course? I took AI in 2019 in college, and you just went through a semester's worth of content in a much more engaging and interesting way than what we did. And I'm just, all you have to do is get coursework, right? That's the whole class right there.
Let's work on it together. Thank you.
Has anyone ever had to or heard of these positions in their companies? Show of
That's
hands.
the previous slide.
Data scientist,
Go back to the
data
Data
engineer,
science, sure.
data engineer, analyst, yeah, data scientist.
Yeah, but I'm sure
That's the one. And that's not yet. The last one's the only one that's new. Yeah.
MLOps is one of the hottest and most in-demand positions right now. If you search for
DevOps.
That's the same.
DevOps.
Yeah.
DevOps.
yes,
You talk to them. College kids, I don't know There's why.
Machine
AWS DevOps.
Mhm.
Man, there's someone out of college with 1 year experience and making $180,000.
yes.
And they can't find enough people to do it. It's not true.
And it's exponentially high in case of MLOps because it becomes a niche and then like there's a lot of demand for MLOps because of the ongoing and machine learning projects and the kind of demand that because everyone is trying to implement AI. Very few people know what's going on in AI.
Yeah.
Every CIO is just about implement AI, do something.
Yeah.
Right?
Do something
Just
so
do
that we
something.
tell people that we're doing something.
Exactly.
We're about to do something. I'm not sure what that is.
Non-Salesforce jobs to pursue. Starting to feel like that.
Okay, so Karthika, you can take it over.
You doesn't have any roles
I'm
of
this
clear,
person. already that.
no validation for all this.
Near me.
Validation as in?
I mean, how it is working, you're building something and
Mhm.
there should be a quality analysis.
That model validation, which is part of data scientist.
So it's not a separate role.
No, because
The data scientists will do that.
yeah, because when you're building the model, if it's not validated or if it's not working as expected, your job is not finished. Like data scientist has to ensure that the model that comes out is actually predicting what's required.
But that's a use case test. It's not nothing but a entire quality test, right? How it is working, that model.
Like entire quality test. So when data scientist has to create, like when we start creating models, we also have to ensure that the final accuracy. I'll talk 2 minutes about it. Okay, just give me 2 minutes. So there are different ways to validate your model. Accuracy is just one of them, and I'll slide it. So if you have a classification model, right? Right, I can do that. If you have a classification model, you have a thing called accuracy, which means how confident the model is about this being X or Y, right? Now let's say we have a model which predicts the difference between cats and dogs, right? And it says that it's 94% confident that it's a cat, or it's 99% confident that it's a dog, right? That is not enough because I'll tell you the reason. Let's say in my data set, I had 99 images of cat and 1 image of a dog. So it's overtrained on cats. So no matter what it sees, it will keep saying cat, right? So and because in your test set, let's say you have 9 images of cat and 1 image of dog. So 9 times it will be correct, 1 time it will be wrong. So you will say my model is 99% correct, right? But actually you have overtrained. There is a bias, which is wrong. So this part again comes back to the data scientist that you have to ensure there is no bias, and accuracy is not just one of the measures. It's required, but then you have to look into different things. 2 different things are FAR and FRR. This is called false acceptance rate and false rejection rate. So, for example, let's say COVID, right? They built many models to predict, to classify whether the person has COVID or not. When you did that test, that was passed through data set, and they had historical data sets, and then they tried to predict whether you had COVID or not, right? In this case, so you have a different value for both of them, right? And depending on the use case, it's okay to have this high or this high. Like, yeah, there is a balance, right? So in case of COVID, if you have a false rejection rate, that's risky. If someone has COVID and you say that person doesn't have COVID, that's risky. So you have to remove the FRR, right? False acceptance is fine. Even if you don't have COVID and the model says you have COVID, it's fine. Like you're not going to die because of that, right? Let's reverse the thing in terms of detecting cancer, maybe, right? So in that case, if it has a false rejection rate, again, that's dangerous because you had cancer, someone has cancer, and it said the person doesn't have cancer. So that person might not go through that treatment that was required. So these 2 things, like it depends on the use case, whether which should be high, which should be low. For example, face detection in terms of tagging people on Facebook. It's completely fine to reject the okay person, right? Like it's completely fine that it did not recognize me as me.
Mhm.
It's fine. But if the same system is used for someone entering into a building or something like that, it recognizes me wrong, like it recognizes me as vegan. So that's completely wrong. So there it shouldn't be allowed. So based on the use case, you try to move these things up and down.
Or if it realizes Felix is in North Korea going into a
Yeah.
consulate. It's like, oh, he's there. That's a
So-
problem.
This is used in terms of classification. Then if you come to regression, there are more things like F1 score and F2 score. This is mathematics, but just to tell you a bit about it, it's like a confusion matrix. So for example, I make cat and dog, cat and dog. So how many times it predicted cat as cat? How many times it predicted cat as dog? Again, how many times it predicted dog as cat and dog as dog, right? So this is right, this is right, this is wrong, this is wrong. And then there is a formula of that to square these and add and divide by the total option. Not going into the mathematics, but these are the things, kind of validations that you do. Like again, there are many validations. So that is why it's not part of a QA, like there is no different QA role here, because this involves a lot of mathematics and it's part of the data science. Like when you're building models, you are doing these things in parallel.
Or is this FAR like false positive? How often?
Yeah, so it's called false acceptance rate, false rejection rate, and it's false positive, false negative. Short, yeah.
So when you
How's
said
it
the
test for-
example of Canada,
Mhm.
Canada flight example,
Mhm.
so if the testers are really good, then they can caught the sarcasm as well, right?
In that case, it's very difficult because that's not an existing use case. Like,
Yeah, those are the edge cases.
right, it came,
Because
and-
data scientists can't think,
and that's the difficulty in the LLMs, like because you don't know what the user is going to input, and even the outputs are generated at the go, right? So if you read about how OpenAI is like, if you see the responses, if you ask it a coding question, it gives you formatted in a coding format, right? Like you see a Python code in a proper format thing. So how they have done is that they have a lot of people who have manually asked questions, and then they have created models which are that if question contains these words, the response should look like this. So a lot of manual work has gone into that.
So they've actually put their own, like built their own intelligence.
Yeah, and
Like
that's how I talked about that model, right? Like that research paper, attention is all you need, that Google wrote. And that's what initiated OpenAI's work. Google did not think that way. They wrote the research paper, but OpenAI had the lead. That's the good thing about open source. So what they did was they went back to the blackboard or the whiteboard, and instead of all these LSTM and all that, they said, let's think about how humans learn or how the babies learn to speak, to talk, right? And they have the letters, the words, and they form the sentences, and then they understand the context. For example, a kid, when the kid starts hearing about a lot many times, they start using it. And then they start asking questions, why are we using it? What does this mean?
Mhm.
The same thing that was used in OpenAI's model training. Initially, they had a lot of people manually entering data, manually questioning, and manually getting their answers. And that's how they have built the model. It has like a lot of millions of dollars have got in that.
Wow.
So,
How's it test for like causation and correlation?
that's what.
So like causation, like, like the story of the
Mhm.
who uses Xbox and credit card companies would say, well, it's 30-year-old women.
Mhm.
Well, no, but 30-year-old women, kids get their mom's credit card,
correlation.
you know,
So, yeah.
which that would could introduce a lot of bias.
Right, and that again depends on what kind of data we have. Like, let's say we don't have any data which tells that there are kids who are actually buying that, right? It's also in the data, it will only show up that there are women who are 30 or 35 buying Xbox. But that's where the business comes into play. That business can tell you that, hey, our end user is someone who is below the age of 20 or someone. And then you try to find more data related to people who are under 20, and then you try to correlate that data.
So you're just like constantly telling the model, right? Like you ask the model, like, hey, who buys Xboxes? And it's
Yeah, and the
like
model
30-year-old
tells you that there are women above 30.
Yeah.
That
You
doesn't
say
make
no,
sense.
actually, it's
Yeah.
actually that they're buying it for their kids. And the
So
model
you
learns.
don't tell it to the model. You try to build another model where you try to collect more data about the kids,
Ah.
and then you try to relate those things that these kids are buying the Xbox.
Isn't that like just negating what the first model is saying?
No, it's trying to combine both of them and then making a point.
Kind of adding to it
Yeah.
to say 30-year-old women will buy Xboxes if their kids are
Just think
used to
about
buying
how
new
you-
Xboxes.
how you will process this
So
statement.
then the model will say 30-year-old women will buy it and then they're.
So just think about how you will process the statement, like just forget whatever reasoning you have. If you are
Yeah.
given the statement that 30-year-old women are buying Xbox.
If I'm an alien, I'll be like, okay, I guess 30-year-old women.
That's fine, right?
will buy
But
the
then you'll be
Xbox.
given more context that they have kids who play Xbox.
Right.
So now you have more context, so you will understand that because they have kids who play Xbox, they are buying it.
That's an inference I'm making.
Yeah, and the same thing is that we are trying to replicate in machine. That's like the whole idea behind machine learning is trying to imitate what we do, how we think.
And one of the cool things about that is if you start thinking about companies that have their specific data sets,
Yeah.
you can start building your own LLMs with those data sets that start saying, this is a better representation of our customers. Maybe the people who buy the Xboxes also know that they have their kids who are playing
Playing it,
like
right.
FIFA or God of War
Yeah.
or like
Yeah.
Modern Warfare. That's not going to be a 30-year-old woman playing
Yeah.
those games.
I mean, I guess
Maybe
like
it
a
is.
bad model might like then
It could
infer
be.
that, oh, these kids are robbing.
It could be. It could be.
their
But
Xbox.
like but you essentially have all of those pieces of data that only that company has access to be able to make that correlation to know that their user base is now accessing this in these certain fashions. Instead of having it generally available data, you have more specifics to who's operating on your stuff. That's pretty cool. to
Adding
think
to
about.
that, like the 30-year-old woman is buying the Xbox, then the model will be trained as if they will keep a condition like what are the other transactions she's doing. If she's going to a baby shop, a gift box and everything, or else if she's going to the restaurants and pubs, she's not like she gave a gift to his boyfriend or something. Like that way, like they see the relative transactions or something, or insurance or anything else.
Don't try to put us in the gender bias over here because of the.
You can tell that
I know.
Target story.
I will.
You remember that story?
Yes, I.
The thing that Target did.
Yes. Right. I am quickly going to get to the demo, but before that, there's one thing that I wanted everyone to focus on, and that is you can have the best model, you can have the best engineers, but nothing's gonna work if you don't have the right data and if you don't have that in the right shape. So to demonstrate that, let me just put something over here. And so here are some points, some data points, and I'm gonna ask you guys if I wanted to draw a straight line, which is closest to all these points, is this the correct line? Is that the correct line? Or is this one better? Which one would you choose? One,
Middle one.
or three?
The middle one, yeah.
Two? Two?
Two.
Everyone goes with two, right?
Yeah.
That's because based on the data we have, you're able to make that prediction that, hey, number two is the best. However, over time, you figure out there's more data, right? And most of that is like this. So now you're like, maybe it's one,
Yeah.
maybe it's not two, right?
Mhm.
But the more the merrier, the more data you have, the better your models will be able to predict, get trained on. And sometimes you would not know this without getting into production, and that would suck. But that does happen. One thing, coming back to the gender bias, I'll quickly walk through an example, and then we put this into use using Einstein, which I'll share again. And then this, however, would be a case of regression. And we get to that versus classification in a bit. All right, quick story that I wanted to share was regarding Target. They were doing something with AI without telling the customers. There's nothing wrong in doing that. So they were using all that data and then they were trying to market to everyone individually. So you and I are neighbors, we get flyers from Target, and then why would I ever suspect that you're getting a different flyer than me? Because it's Target, they're distributing flyers. So right. one day what happens is, and this is not me, okay, I'm not that old, but I'm old. I get a flyer and it says, buy these baby products. And I'm like, that's weird. Why would I need baby products? I've never shopped for baby products. And then it keeps doing that for weeks, and then I'm like, don't get me. Oh. So I go to Paul and I'm like, hey, what's up with Target giving all these stupid ads about baby products? And Paul's like, they're just making me shop for beer. What are you talking about? I'm like, no, I got this flyer for baby products. So I go to Target and I'm like, hey, what are you trying to do? I have a teenage daughter and you're trying to sell me baby products. Are you trying to get her into something that she shouldn't be in? Make a big deal about it. And then later on, come back home, weeks later, find out my girl was pregnant. And I did not know about it. Goes back to Target, apologizes. And that's when Target revealed that we have this AI thing going on based on the products that you buy. It predicts if you're pregnant or not.
How did it?
And
suicide.
Oh, of course. That's always the last step in all of this.
How did they know that
She had bought like a pregnancy test.
they know that this credit card belonged to this address?
Dude,
Well, I think they know.
Really?
Oh, everybody
that's
knows.
a very
Yeah, they know.
So-
that.
That's easy.
Yeah, privacy is a myth.
yes.
I'm worried Waze is telling my insurance company that I drive too fast.
Don't use baseball.
All right. Coming back to the demo thing.
Yeah, share it again.
The version of that story I've heard before is like the person did not know they were pregnant before like Target knew they were pregnant.
So the teen girl's dad got to know and he too Target.
All right. So we are quickly going to walk through a simple scenario over here. This is Salesforce, as some of you may know.
Whoa.
And, yeah. And this is the Energy Cloud, a quick demo that I could put together. So how cool would it be if I could predict the usage of my customers? Just stay with me over here because there's limited data that we are predicting on. Seems like a cool use case, right? If I could predict the usage, I would know how much units I would be consuming as an organization and then buy energy accordingly. So it saves money. So I've been told.
Or offer the right product
Right.
that makes them the most money and just doesn't give you the ones that you can make less or you have to
Spend less.
yeah,
Yep.
spend less.
That's business.
Yeah.
So we have this billing data available, which basically shows me, usage data, which basically shows me over a period of time. Not that one. Over a period of time, day-wise, it's too small, but I'm going to zoom in a bit. Not helping. But it shows day-wise how much usage I have. Now, I already have that data. Now, if we wanted to go through the traditional machine learning, which I'm going to just share for freaking you out, but we're not going to go that route. What we traditionally would do is have the feature engineering going on, figure out the correlation metrics between all other objects and fields, how they're related to each other, and then figure out, hey, maybe this is some field that I can use to predict what the usage is going to be like. And based on that, then I could, plot a graph and see, hey, is this matching with what I've predicted or not? Now, because as Vishal mentioned earlier, there's a lot of things that has gone obsolete, including the feature engineering. Not that you can't do it, you can still do it, but it's better to not do it.
In a lot of cases you won't need it, but you'll still need it when it's very specific.
Right. But it's good to know that how it's supposed to be done or how it's working underneath. Coming to Einstein, again, for me, it felt like a black box, but I was okay with that because I knew what I was getting into. It was supposed to be a black box, which helps us make a prediction without me getting into the mud a lot, right? So the way you would do it, and I'm quickly going to walk through that, is you can go over here. Let me just start from the top. So you would go to setup. You would do what I do is search for Einstein, go for prediction builder, and then start creating a new prediction. Now, before you do that, obviously you need to know what you're going to create a prediction for. So looking at this page, I'm like, okay, so this is what I want to predict for. This is the detail. You need to know beforehand what is the object you're predicting for. What are the fields that you're predicting for? So in my case, this is going to be, and I'm just gonna call it Mark 4 for now. We're not actually gonna create it.
Also, in the bottom, you see yes, no, or numeric, which is basically classification or regression that we talked about.
Why don't they just say that?
Because that will be complicated.
Yeah, it's gonna be complicated. As I said, it's going to be a sort of a black box, but underneath, as you know, Vishal told us, it's all going to be either a regression or classification. So on the left, you see there's classification. We're gonna go with regression. The reason being, we are going to figure out what is going to be the predicted usage. And usage is a number. So a number cannot be 0 or 1. If I wanted to say, will this customer churn or not? That is going to be a classification problem, and that would be a yes, no.
Is regression always a number?
Yeah.
So it's a percentage of churn.
Like a probability? No, regression is a point in number line. That is what you try to predict a number. But fun fact, linear regression model can be used to do classification.
Will not get
That algorithm is used to do that.
Multi-class classification, this is what kind of for these things?
Mhm.
So when we need to predict different classes, not 1 or 2, but 1, 2, 3, 4, 5, and more. So what is this?
So if it's just yes and no, it's called binary classification.
Yeah.
Otherwise, it's called multimode classification.
Yes.
Yeah.
So, but this doesn't allow us to do.
This default doesn't. You have to go to a different type of prediction, which
Ah.
allows you to create classes.
Okay, thank you.
It's a basic.
But this would serve your appetite right for most of the use cases that you have. I'm not saying that multi-class classification is not a use case. It is, but you know, that is not provided right here out of the box. It's like, hey, majorly people are either going to have, hey, what's this number going to be, or is this yay or nay?
Yeah.
Right. And that's one thing.
You can also do, is this a cat or not? And then is this a hairless animal or not? And then you put the two yes, nos together and you know you got a hairless
That's how
cat.
the algorithm works.
Yeah.
What you said, that's how the mathematics works behind the scene.
Perfect.
So you're saying if we want more than 2 in the classification, we have to do our own or buy something else and not out of the box? Is that what I'm hearing?
It's not available here. I have used that in the past. I don't remember which option gets that, but it is available in Salesforce where you create different classes in the part. Maybe it's because of the data that you have, Kartikya.
Probably.
Yeah.
And there's always a way to hack the basics versions.
I'm just curious. I'm just saying.
Salesforce is not our forte, but yeah, there is a way for sure.
Right. Going forward, now that I've figured out what I'm going to predict, I've just named it for now. I haven't even told it what object, what field it's going to be. It's going to give me an option of what object and what field is going to be. So I know it's statement item. I'm just going to choose that. Hit next. It's going to say, are you going to train this on all of the data, or do you want to do it only for a subset of the data? This can be useful if you say wanted to have it as a pilot for, let's only do it in New York right now, or let's only focus on Texas, even though you serve other states, but you only want to focus on one state or city or, just one.
Residential or commercial?
Exactly. So that can be done over here for now because, I only have limited data. I'm just going to go with all statement. It's also recommending, hey, this is the most common one. I don't fall for that. Right. Then it's asking what field you want to predict. Now, again, by intuition, there's no way I'm going to predict the account name or account ID, though there may be use cases for that. I'm going to go ahead with usage. And I'm going to go ahead with all records that have a value for user. Again, I can specify which records to do.
Can you point this towards Data Cloud now? You can.
Which is a really awesome use case for Data Cloud. It's essentially an integration layer for you to go into and out of SageMaker, Databricks, and other external AI models as
So you can
well.
point it towards the zero copy data too.
Then it would ask you, hey, what do you think would serve me best towards this prediction? Now it's doing the same thing that I was showing you a bit earlier, saying, hey, this is the correlation metrics. Based on this, what do you do? Over here, Einstein, because again, nothing against it because it's a black box, it's intended to simplify things instead of making you feel like, hey, this is so complicated, I can't wrap my head around it. It's giving you a simple interface of choosing what fields you want. You can either choose or you can go with all fields and then later on realize it's wrong. And I'll get to that in a bit. Say if I went ahead and
Because there's like rich text in there.
yeah,
For
Rich
example,
text.
someone's name doesn't have any correlation to the prediction of the users, right?
Yeah,
Right.
phone
Create it.
number.
That's wrong.
So you want to
Email
take those
address.
out. You,
Yeah,
or
things
you
which
get a
are not
better.
related to the user.
But you can only point this towards fields. You can't point this towards other objects.
from this interface, no. There's way to do that too.
Sorry, what was the question?
So like if I wanted to predict, is this opportunity gonna close?
Mhm.
Are they gonna renew? Are they gonna renew? Well, maybe I'd want it to go look at cases.
Yeah.
And they get like a really sentiment, would be great. Like they're really pissed off.
Yeah.
Probably not gonna renew.
What you could do is build a trigger that populates a field based on the aggregation of cases or like data about the cases on the
Oh,
object.
Yeah.
And then that's going to use that and that'd
That's why you
be
get the
pretty
big
cool.
bucks.
That's not true.
But so you cannot combine multiple objects or data from.
Not through this interface straight away.
Okay.
As Keegan suggested, there are ways to doing that
Some
if you
kind of
still
roll-up.
wanted to use this interface.
Okay,
And not going to the point, but he and team actually use their own model on top of Einstein. So that is allowed as well.
okay.
So, but for the
That's where the
demo,
big bucks are.
all right. And then, so you select your fields, you hit next, and it's gonna make you choose what all records it should go on. And because most of my records were created as example records, I'm just gonna filter those out and then put a dummy filter over here for it to be happy.
Have you used this before interface? I used this back in 2020 and they had a thing called next best action NBA.
Oh, yeah.
This was way different as it's supposed to now.
Everybody gets 2 free ones too.
Is that Einstein thing? Gosh, never worked for me. They would just crunch and be like, oh, data wasn't good enough or something.
They only said you use random forest or linear progression and then this is what you expect. And so that's what they provided you, the output as.
But pretty neat interface. It's gonna ask you, hey, this is what you've selected. Are you sure? Go ahead and build it. And you can go ahead and build it. It says it can take from half an hour to 24 hours.
I don't know why it's in the.
Uh,
Why is it say quickly? Yeah.
yeah. So again, we don't know behind the scenes what it's doing, but it's taking care of everything from choosing what model you should use and training that on your data. And it's going to start that and then it's going to take us to setup.
So it's essentially it's creating those neural networks and those relationships across those data fields and records to say this is most likely correlated along these
And
lines.
it's using the model itself, so
Yeah.
it must be using a lot of different algorithms and then finally coming up with the algorithm which suits it the most.
Awesome.
Because at the end, it's going to use some algorithm,
Yeah.
some model, and then train that on your data. Now, it's not asking you to do that. It's not forcing you to make that selection or that call. It's going to do that for you. So while that is loading on
Yeah,
Salesforce,
What are we trying to predict? The usage?
the usage.
For the records that doesn't have usage,
No,
based on the ones that we have.
it's going to predict the usage based on the records that have a usage, but it's going to predict that for existing records too. Like you could still compare it. And that's how you get to scoring it that, hey, is this close enough or not?
So you already have the usage, but it doesn't see the usage. It tries to predict it, and then it says, I predicted this, the original was this. What is the difference? And that's how you validate it.
One thing I think we both skip is whenever you're training your model, you have say 1,000 records. You don't train it on the 1,000 records.
Yeah.
You train it on a subset of that. And another subset is used for validation.
That's
So,
generally 80-20, like you
Right.
hide 20% of the data, because
So-
if your model sees all the data, it's
so if you have
cheating on it.
It does that automatically, or you have to tell it to?
You have to test.
This does it automatically, but if you're doing it like you're coding it, you'll have to do it yourself.
It used to ask us to like choose some records.
Yeah, it asks us, right? So when you were selecting, it automatically does that split.
yeah. It's not gonna ask you, hey, how
Gotten
much?
better
Yeah,
from 3 years ago.
exactly.
Yeah.
So, it's gonna split that as, hey, this is my training data. And this is my, let's just call that validation set.
And we
This-
trusted to like be honest about it, not be like, oh, this data like creates a very nice looking model. So
So the problem with doing that would be then your model would be trained to do 100% on the
Right.
data it's trained on,
yeah,
but it would fail to serve any new data
Right,
that comes in.
right.
So going back to your question, it's still going to be able to make prediction and it's not gonna match 100%. The reason being, it's not gonna train on all records. As I said, like over here, you would, if a new entry comes in, it's not gonna fall. Say if we went ahead and chose this as our model, if a new data entry comes in, it's not gonna land on the line, obviously. It may not. But that's something that I think we skipped and it's important.
Do you know if it takes that 200 and split again, do another split
That's like by default it doesn't.
and keep training until and find the
That's a way. There is a way where you do that, but like by default it doesn't. When you're
But
doing
is
manual
there a-
training, when you're doing manual training, you actually do that. But then there is a three-way split: train, test, and what's that? Validation.
Mhm.
Train, test, and validation. Then you do like 85%, 10%, and 5%. 5% is not even seen while testing. That's treated as production data, and that's treated when you finally have it.
Then are you thumbs upping, thumbs downing it?
Yeah.
The prediction.
Yeah, and also
That's
this
cool.
this validation set for the next iteration, it takes a different 200 records and keep the other 800 as the training set. And
Not in this case, and we do that sometimes, but there is a downside to doing that. At the end, you will end up seeing all the data.
Yep.
So that's why you split a certain set that you never see. Like your model never sees that. Otherwise, it's cheating on you.
Yep.
Like that's cheating.
Is it tagged to know that it was
Yeah.
trained on?
Yeah.
Okay.
That's cool.
You will need to, it will need to do that. Otherwise, if it sees the entire data, it's game over. You now have a model that works flawlessly with your data.
Because it's already seen it.
All right, so we do that over here in Salesforce Einstein, and then it would go ahead and start the processing and maybe take 30 minutes. Again, we don't want to do that over here, wait for 30 minutes, though I would love to talk to you guys. We're not going to do that for 30 minutes. I'm going to show you what it did historically when I chose different fields, maybe same fields too. So let's look at this one, which one's Mark 2. It's ready for review. I can view the scorecard. So it's going to give me a scorecard. It's going to tell you, hey, this is my prediction quality. It's too low. And in this one, I'm just going to say, I think I used all the fields. And it was like, I cannot make heads and tails. But there's an account ID. Is it based on account ID? Is it based on account name? So it had a very low prediction score for that. You remember the correlation we were talking about? So it would also have correlation. So you can go ahead, look at this, and then use this data to fine tune it. Again, it would take a little intuition. Maybe just watch his video 2 times and that should help. To figure out, hey, what all should I do? What all fields I should be removing in order to make my model perform better.
And that's a hidden trial. Like
Right.
sometimes the fields that you think won't make any sense are actually very important.
So in this case, I had taken a few fields out and it was actually able to say, hey, temperature is highly correlated. Like, it's having the most impact. and which does make sense that based on the temperature, you can make a guesswork on, hey, is the usage going to be high or low today? And is the temperature too high? I use it. Is it too low? I use it again. Is it pleasant? Yeah, no one's gonna, crank up their air conditioner today. So maybe not that much high usage. Again, depends on a lot of factors. Is it a residential unit? Is it a commercial unit? For example, in case I had this with commercial unit, day of the week would have a high correlation too, because over the weekends, you'll probably have lower usage versus on the weekdays. So with Einstein, you get these predictions created for you, and then these are available for you to use as fields. So this is your prediction name, your API field, and you can go ahead and plot these over your layouts on the reports that you need. Again, I wasn't able to do that for this demo, but what we do have is, so for this particular account, you have a lot of data, and then for that data, you could go ahead and view the statements. And for each statement, you can see we have statement line items. For each day, you would have a particular usage, and you would have, I'm gonna go to incognito because that one wasn't here. You have a particular usage, and then there's a prediction user score. As you can see, this one is more off than the other one, and this was the one where I used every field to come up with the prediction. While over here, I was like, let me try to act a little smarter, but I'm not gonna do this as a production case. So there you have it, nice and easily done. You did not have to do a lot of heavy lifting. Einstein was able to do that for you. Einstein also came up with a lot of other products that we're not going to cover over here. It also now many of you may already know, it came out with, now you can have natural language queries to help you figure out questions that you have. So if you do not know SQL, that's fine. It's going to do that for you. Problem with that again is hallucination. You can ask it, hey, how much usage would this account have? It's probably going to give you a number. But if you do not have this generated for you, it's going to give you a random number. So it's, use it with caution.
I think, has it come up with conversational AI or is it in the process? I did see you.
Me?
Yeah.
What?
I said, I didn't come up with the conversational AI. I think for development, it's trying to do that.
The conversation layer?
Yeah, just conversational AI, just like GitHub Copilot, they're also starting something.
Yeah, develop Salesforce or Einstein for developers.
Yes.
It works pretty well. But you have to give them very small methods for it to go generate. So if I want to give you these parameters, I want to expect this for parameter, and I want you to do these things. If you give it that and it's a very small thing, it does a great job at giving you individual methods, and you can string it back up together by just creating the initiation method and then just pass the variables across.
I think VS Code has launched the plugin.
Yeah, I've used it many times. I actually could do that now, but we might just hold that for another session.
Yeah.
But this is awesome. This is fantastic.
Have you seen much advancement in the last 18 months on this prediction builder? It feels a little like a forgotten product. I mean, 18 months ago, we're talking about this constantly. And I don't think I've heard it mentioned.
I think the end products, be it Einstein, be it GitHub Copilot, are always lagging behind because there's so much advancement going on in the field of AI. You wake up and you're like, the book I bought, is obsolete. That was happening, which is okay. It's a hard copy. Then you're like, this article I read, which came out yesterday, it doesn't make sense anymore because they've already solved it. We are at that point right now. So obviously you would see the products, go from version A to version B, and then it's like they've changed a lot of things, but it's because they have to. to, to generalize and then to make the most out of what's available
I
right now.
can say that Einstein is much better than how it was in 2021 when I used it.
Oh, Einstein for sure. I just mean prediction builder in particular.
Mhm.
Prediction builder feels like it's been kind of stale. I don't know if you noticed that.
Not sure about that part.
Yeah.
But like when I used Einstein, I mostly had to like bring in my own model and do that part. So at one point, Einstein was just a bucket with my own model. I didn't understand the point of using it.
Yeah.
But now it's much more better than that.
So they're working on the back end, trying to
Yeah.
get the data trained up to do all this regression and validation to build out its neural networks to be a little bit better than it was before and make the correlations better than it was before.
And I'm pretty sure Salesforce has big teams trying to figure out, hey, with all these velocity products that we have, these are the 10 use cases that we can have. How about we just sell the models for them
Yeah.
Yeah.
exclusively?
And that's why they spin up a new cloud.
More licenses.
Yep.
Yeah.
But the closest might be only
Yeah.
$50 a year.
Now there's 50 plus different SKUs of Einstein models.
There is.
Yes. There's more than 50 things someone can sell you that's labeled Einstein. If you ask your sales rep, I'm sure they do not know any of the SKUs. So they'll be just like, let me get you a list of 50 and I'll try and this one. I'll give you this one.
You had a question? You had a question?
Yeah, so we still have demo of, how we can use our own model. With the,
Not
We don't
for
have that.
today.
or just walk through.
Not yet. Today.
But the good thing is with all of this understanding, this all kind of drives you to understand what are the main concepts of what Einstein does underneath the hood. Because what Einstein has done is they made it simple, super simple to where it's just a black box. But really it's this stuff that they're doing in the background that gives it that black box feel. And there's SageMaker is a pretty open thing. Yep. Yep.
Oh, okay, so that's where you build the model?
That if you are building it on Amazon, like AWS, it's SageMaker.
Okay.
If you're using Google, they have Google AI. All of them have their own thing. Azure has Azure.
So can you talk at the high level exactly what happens to replace this with your own model? Like,
Yeah.
let's say we have an Azure, because we do, a model. Okay, so if I want to hook that to our Einstein, I just need someone to talk me through what does that look like. You don't have to show it to me.
Yeah, when I did it in 2020, I think, we had that churn prediction model and we had to plug it to a Salesforce dashboard. In that case, we had our model on our own server on EC2 AWS. We exposed that via an API. And in Einstein, we had an option to get the output from an API. So I just put my API in the token that I had, and it was getting that prediction. And then it was making more inferences on that prediction, like doing all the correlation on that. But the final prediction was from my model.
So is that like, do you create a connection, a connector, and give it like an endpoint? And
Yeah, when I did, like Einstein had an option of putting in your API path and the token, that's it. And mapping the variable that you have, that's it.
But you pull the data out, but it like in Trino or Iceberg.
Mhm.
And do you pull the data out of Salesforce to run your model?
Yes.
And you
We had two
store it
sets.
in, what do you store it in?
We had it on our own database, MongoDB. We pulled that out, we trained it, and then we again pushed back the output.
And then you just use that one connection point, that API connection to pass the new variables in. So it works off of,
So
it
that's
gives
the
you that
advantage
protection.
of having your own models. You got to pull all the data out of Salesforce.
Yeah, we have to have that pipeline running.
Yeah. So like daily, you'd be pulling things out. You'd have something say, is this a test, a training piece? Is this a validation piece?
Mhm.
And you have to be able to manage how you add that to your existing model.
Versus over here, you just select the fields, new data comes in, it keeps improving on that. I'm gonna go back and then get see it because there's not much. This is the end of them.
So how it is different from a generic reports when we are creating something on the Salesforce data itself? Because, for example, you're given something on the status itself, right? So how much more it is matured and predicting it? It's like you can also create a report on the sales website, right? With using the same kind of data.
Yeah, but report won't be predicting it, right? Like we had two fields that Karthik had in that particular dashboard. One was the actual usage, the other was the prediction. In report, you won't be having the prediction. You'll only be having the actual usage. The prediction that the model is making that this particular user on this day will be having this particular usage, that's based on a model. That has to come through any ML model. That cannot be done through any reporting.
Now, isn't that like, okay, so you extract data from Salesforce, right? Through a connector somehow. You push it to your LM, it turns, crank out a prediction. That prediction for each of the record that you feed it, right? Come back to Salesforce, right?
We could do it that way, but that's not ideal.
Right? I told them that way. It will call inside Salesforce. The content, right? What you said, that's also possible.
Right, and then that field that you predicted in your local LLM or whatever, right? It's now it's gonna be written in a field, in a custom field in Salesforce, right? And the report can display any field that is in an object. So, I mean, it's being fed by something, and you write to it. Now you just display that in a report, no?
So once it's back onto your object, yes, you can create a report out of it. So, and that's what I was mentioning, that it would be good to have a sort of a graph which shows, hey, this is my usage and this is my predicted usage, so that you could see it in action. Like now, once the prediction is made, be it using Salesforce Einstein or using your own model in Salesforce Einstein, you can then use that field to do whatever you want with it, like a normal Salesforce field.
Right.
I think I understand you. If I understand your question correctly, imagine you have a chart bar.
Right.
That's working on your data that is saved on somewhere else. Then you're not storing that anywhere, but still, because you have that API, you can chart it from within Salesforce, but it's still generating the responses, with your data from Salesforce, querying the model in somewhere else because it is exposed via API, and then giving the responses in real time. Yeah, does that make sense? That's what it was.
Is there any latency time to get it from AWS back?
Yeah, that will depend on how fast your inference API is. Inference is basically when you query your model to get an output. That depends on a lot of things, like what's your GPU, like how your system is configured, how optimized your model is, how optimized your code is.
So how is that generally, like very fast or?
Like if you look at ChatGPT, that's quite fast, right? They are not short on
the
infrastructure. That again depends on data. Like the one that we had for churn prediction, we had it like less than a second.
How are you gonna make sure that prediction is accurate or not on the Salesforce?
So it doesn't depend whether you're doing it on Salesforce or you're doing it yourself. When you're doing the data science part of it, like right now we saw where Karthik used all the fields and all that, and he saw that there was a huge difference. Like the actual usage was 83, but it was predicting 103, right? It was off by 20. So when you'll start training your model, you will see those differences. The validation that I was talking about, that what is the percentage of the prediction being off from the actual thing, and then you will try selecting different fields, try selecting different model, finding the correlation, dropping few fields, adding few fields, looking if you have null values somewhere which is causing this. So you will have to understand the data more, visualize it, and once you start making sense of data, you will figure out things that that totally depends on your business knowledge or the problem you're trying to solve. For example, like Karthik had everything included in the first case, and he had a very bad prediction, right? Because it had even the account number and name that was being used to predict. Like someone's name doesn't determine their usage, but it was being used in the model. But similarly, there is a very famous use case of Titanic data. That's like a hello world machine learning, where you have historical Titanic data and you have to build a model which predicts which passengers survived and which died. Right? You have different attributes. And if you look at it first, you will think attribute like gender should be removed. That doesn't make any sense. Right? Based on your gender, you won't survive or die, right? But actually, if you look at the correlation, females had a higher probability of surviving because when the Titanic was sinking, they had a rule that
first the females will go, then the males will go. Similarly, the coaches, like whether you're in a business class, first class, second class, or the lower class, people in the business class had higher probability of surviving because they were given preference. So in the first go, you will think that this doesn't make sense. Similarly, children had higher probability of surviving because they were trying to save women and children. So it depends on the use case. In that case, gender did make sense, but in this case, gender is a gibberish input. Like somebody's gender won't determine the usage. It might, but that's why it's just like it might.
Complain about someone using too much energy in your home. Like we have the Titanic. Use a lot of energy.
Right. So it totally depends. You have to understand the use case and then keep experimenting with the data that how far off your prediction is. Because you have a predicted value and you know the original value. You're seeing the difference. So try doing different stuff and try to bring that closer and bridge that gap.
On Salesforce Einstein, again, I'm not going to share it again. But if you saw there was a needle which was showing, hey, this is low, okay, good, or awesome. So yeah, again, that is extracting it, but it's doing the same thing, trying to figure out how good the prediction is, how off it is from the actual value. And based on that, it's going to give you a score. If it's low, then someone needs to go in and change a few things over there. And it's not going to, so once you train it, it's not going, the needle's going to keep moving as you put in more data. Later on, you might realize, hey, I'm giving this field as a bad input, or, I'm not considering one field that should be considered. For example, there was another field over there when I was working on it. It's called amount. And I was using that field, and it was like, yeah, based on amount, I can predict it. And I was like, no, wait a minute. Amount is a field which is directly related to the usage. So it's like, an alias to usage, because if you know the amount, obviously you can tell the usage. So don't use that field.
Yeah.
Mm.
It's like using the stage given opportunity, right? If it's close one, it's close one.
Yeah, so you're creating a bias very clear. Another example in a different use case is there is a famous data set of Boston housing, like it's 90s, but it talks about different, again, the same thing, predicting price of houses. And another example of California. And if you look at the data set, it has latitude, longitude, which in first go doesn't make any sense. But when you try making sense out of it, when you plot the data, if you try to plot a graph with every home plotted at the latitude, longitude, and make the prices of, make the color of the houses which have higher price darker in color, you will find everything around the coast has higher price. So that is why latitude, longitude does make sense in that case. In Texas, I don't think it will. It's a flat line. So, these are things which you make sense once you start visualizing it.
So you're gonna bring in some other third-party systems data and also do these predictions on Salesforce, or only Salesforce data?
You can use the existing data, or you can input your own data.
Some other systems data.
Yeah.
Which I'm talking about SAP.
You can create a plugin. You can call that data and push that.
If you use data cloud.
Yeah,
If you use data cloud.
Yeah.
There's a lot of ways to do it without Data Cloud, but you could do it with Data Cloud.
Yes. And that again, it abstracts that thing for you. Okay. If you're doing it yourself, you'll have to write that part as well.
So it's only trained once, right? I'm sorry.
It's continuous learning. Like every time it gets more data, it will try to identify that model drift or data drift that I talked about, that at which point it should update its model, and it will keep on doing that.
When you said a data cloud, it's a separate license, like Einstein in Salesforce.
I don't know a lot about Salesforce.
Oh, data cloud.
Ask these people.
So there's also integrations you can build to bring in data, or you can also have a virtual object that you can use to port data in. It's not a big object. It's just an external object.
External.
Oh,
Yeah.
and Einstein can work off of that?
I think so. I haven't given it a shot.
It should all the updates. presented when which object you want to select or which object you work.
Yes.
So I think it should have that.
Yeah, but the external object.
Mhm.
Uh,
So external objects are really just API calls to get things from another place.
Yeah.
And you're just hitting the API and it's bringing back data. It's not actually storing in Salesforce.
Yeah.
So if you look at zero copy, that's essentially what it's doing.
Yeah.
But then again, that's pretty much everything else that you build with an API outside to go grab information from external systems in. So it really depends on how much you want to spend to not have to build your own APIs, is really what a lot of the Salesforce add-on value is, doing it all for themselves and like helping you guys or helping people and companies use things without having to have code to maintain. That's really where the big value is for a bunch of these concepts like external objects and OData connection, all those areas. Data cloud, yeah. Do you want to pay for it every year or do you want to do it once and have it be capital expense?
Who is dealing with him?
Yeah.
Alrighty, I think that's it from our side. Any more questions?
You're doing a great job as like the owl webcam.
Yeah, I am an owl. Look, I don't have that much. I don't have any experience doing it, so manual labor is what I know.
For example, that if you go on, in goes 10 or 11, that's going to be wrong. It has to.
That's again the job of data scientist, because the data scientist's job is not done until the model is actually predicting something correctly. The data scientist cannot say that my model is 99% accurate, go figure. Because the mathematics or the art of figuring out whether the model is correct or not requires a lot of mathematics. So that again has to fall back to the data scientist.
Yeah, whatever the data is correct or not, or
Yeah, they have to figure that out. But data labeling is another like subset job where people who are who just spend time labeling that this is cat, this is dog, this is cat. They just label it. That's a very manual intensive job. That's not part of data scientist job. Sometimes, especially if you're working for a startup, everything's data scientist job. So from labeling to creating model to deploying, but in a higher hierarchy. That is mopping the floor. Yeah, that too.
Yeah.
It's always important to know that these types of systems also come with maintenance requirements. So don't let CIOs or CTOs hear like, oh, set it or forget it. You don't ever have to deal with it again. You don't have to hire anyone. You probably want to hire someone so that your models are always accurate and present. So like if you need to reevaluate your model because some pandemic changes exactly how everything's going to work, you're going to want that.
Yeah, that's the job of like MLOps and data scientists. They have to work hand in hand.
Yeah.
Like pandemics like screwed all those predictions for the usage of energy, right? Like everything went haywire.
Yep. And you have to know that there's a standard deviation that's being blown away so that you can retrain your models on a new data set instead of leveraging the old stuff, which is going
you have
to
discard a few things. And now, if you talk about energy usage or things like number of people who will get admitted to a hospital and all that, you have to remove that part when you had COVID, because that's a bias again. That's an anomaly. So while training, you'll see different spikes in 2020, 21. That's not generic data. So you have to remove that manually. You have to understand what happened in that field.
Thanks for the presentation. Thanks for the information. It was very affordable and clear.
Thank you.
Thanks for the examples.
Yeah.
These guys are the best. Awesome. Well, I will stop that somehow. I need to figure out how to stop it.
It looks like a spy cam. Like.
It is a spy cam. Look at this. Whoa. No, but seriously, thank you guys for coming. This is exactly what we want, and you guys did a fantastic job. Thank you so much for presenting to the group. And I don't know about everyone else, but I can say I learned a crap ton today. So thank you guys.
Yeah. I did not learn quite a lot of what you said because I was like, I actually learned quite a lot. So.
Guys online, we're going bye-bye. See ya.